summary of our, basically log into our course website, then enter Blackboard or Collaborate. Because anyways, if you don't have it today, it's fine. But starting from next class, you're gonna need this setup to quiz anyway. Okay? So, but just please, if you have your things, just log into the Blackboard or Collaborate. First, all right. So right now is the already the update. So it's official time. So I will welcome you to this organic book. As the name suggests, the second part of organic chemistry. So you already took the first part of organic chemistry. So many of the fundamental knowledge that they are prerequisites. Okay? So I will not be going through. Obviously, I will not be going through everything. What you learn in organic one, but some most important piece of knowledge, I will still refresh them when we start to use them. So the understandable. Not everyone can spend a lot of time during break. They prepare you for the spring semester. So. And let me see. Let me pull out the syllabus. Syllabus. Maybe this one. Yeah. So I will not really read through the entire syllabus. It's pretty long, and I think our time can be spent, the better. Okay? So for those of you who were not with me last semester, my name is Shiji. Here, just the email address is just like first name dot last name at CSI. .edu. And the first, doesn't matter which part of organic chemistry, it's critically important because all the organic chemistry, of course, both organic chemistry courses, is the course was always run in such a way that every step build upon the earlier step. So it's important for you to not be left behind. In the early part of the course, so it's critically important. So if you have questions, you should have your question answered as early as possible. So the college provides the pretty robust supporting system. We have tutoring, that's organic tutoring available in tutoring center, and also there will be organic chemistry tutoring available from chemistry department. But because you're gonna take all those exams, will be made by me. So probably the most reliable resource, we can make use. So it's gonna be me, the instructor. So I strongly recommend to make use of my office hours. So I provide 3 office hours every week. One is the 10 to 11 Mondays, right after our Monday class, and the other one is 3:30 to 4:30 p.m. on Tuesdays, and that is part of club hours. So technically, no one has a class during the period of time. So I made this change just to, I know everyone maybe have different class schedules. So right after our Monday or Wednesday class may not be best time. So I just make if on the club hours happens to I don't have any commitment during the other commitment during the period of time, so I could do it. And so I believe if you really need help, one of the 2 in-person office hours should fit your schedule. And if and the third office hour is online one, 8 to 9 p.m. Sunday, as so that obviously during that period of time I will not be CSI, so that's it's virtual. So you can visit my virtual office hours by just clicking on the Collaborate Ultra. Then you will find a specific room in the virtual office. Then you can find a few days, a list of days. They will by the date, and and only one room will be accessible. So that's the room you're gonna be using. So the importance, and in organic chemistry one, I already emphasized the importance of mechanism. But in organic chemistry two, the importance of mechanism is even greater than organic one, because of the number of reactions in organic one is rather limited compared to the number of reactions you will be in organic two. Yes, the type of reaction in VPC actually is less. The type of reaction exactly, because pretty much each and every reaction in organic two, they are either acid-base reaction or more narrowly defined a reaction between Lewis acid and the Lewis base. That's nucleophilic and electrophilic. But the number of reaction is much more than organic one. So if you tried to get by organic one by memorization, that strategy won't work as well in organic. Okay, so so let me emphasize again. I strongly recommend go with the mechanism first, the pathway. Because if you know the mechanism, you know reactions. If you know the reaction, you know photosynthesis. Okay, so this is a synthesis. Synthesis. The reaction mechanism are three biggest part of organic chemistry. Nomenclature, maybe occasional testing, but never a most important part of organic chemistry. So the mechanism is the key. And the mechanism, we won't really introduce much new things about the mechanistic aspect. But those concepts that bind all those pieces of knowledge together, almost all steal from organic one. One of, if you read the welcome information, one of most important one is like, let's say, the Hammond postulate. That will give you a way to either qualitatively or sometimes semi-quantitatively estimate the reaction rate based on the stability of highly reactive intermediates. And then carbocation stability, that's something we have been seeing many times in organic one, and also nucleophilicity of nucleophiles. We learning chapter 6 maybe, yes. Organic one and the living group quality. Those are the few most important concepts. They serve as glues, or basically glue all those the organic two topics together become inherent body of knowledge. Okay. So we were not really learning too much new concepts in organic two, but instead we're gonna apply those fundamental concepts in organic one and use of them. So, and in terms of learning method, besides the have your question answered as early as possible, please always pre-read the content that will be covered in next lecture. That will give you, enable you to understand the whatever delivered during lecture a lot better, and you could and also ask meaningful questions, and also work on the homework as early as possible, because doing homework not only complete task and also serve as checking how well you understood after the class, and the effort also reinforce and enhance your understanding of the topics, and the grading. If you were with me last semester, you will see that it's pretty exactly the same. Lecture part comes about 75% of the course, 25% from the lab part, and out of the lecture part, a significant part is from the final exam, all inclusive final exam, all you can eat. Okay? You know the final exam. But again, if you do the final exam, you probably know that for final exam there's no really super difficult question, just a lot of things put together. So the and then regular exams, so we can have five of them. For the better ones will be counted. That was totally 36 points. And the quizzes, every day we can have one, and the collectively count 10 points. But usually you will have a chance to add at least 12 points. Usually, okay. So the homework, you know, the total there are 12 chapters. So each chapter was half point. So together 6 points. Basically, you do it, you get it. Okay. So I will not be graded because there's a solution manual there. Okay. So it doesn't make any sense for me to grade how well you copy solution manual answers. Okay. So you do it, you get it. Okay. But you know just for your benefit, it's important to show your work because they just copy the answer from solution does not benefit you. Okay. After all, you know, you are taking the course. I believe from with what I know, organic food no longer a required course for biology majors, right? So you are taking it because you need it. Okay? So please do not just copy the answer of solution manual. You can using the answer from solution manual to help you, you know, improve your way of solving problems, but do not just copy the answer. You know, from the last semester, I actually can see many students direct copy that. I still give you the credit, but that's you are hurting your chance of, you know, learning better in this course. Please don't do that. And also, there's a half point extra credit if you want it. Just you know the signature page. Okay? But you know it's also mandatory. Basically, if you give me before deadline, you have the half point credit. If you don't give me by deadline, you still need to give me, but you don't have the credit. So you know you better just you know do it before the deadline. And the deadline is the first date of the exam. I think I put on syllabus. I will stick to the date. Yes, February 21st. It's a Wednesday. Yeah, that's Wednesday. So now let me see how many of you are in the course. 45? Okay. So let me ask because of the you know the quizzes. Okay, those will be online one. And I also from the you know the last answer to the last question in the final exam from the organic one. A number of you said, oh, I want to have more time on the quizzes. Okay. But and also some of you suggest okay maybe you can put the out of class time for us to do the quiz. I mean, it's reasonable, but the thing is that you know if put out of class time because it's you know it's a sizable part of the course. I cannot make it say unlimited time or any time you can take it because any time you can take. Obviously, you know some took the quiz earlier. You know, we'll see the feedback and tell the student will be taking it later, and that's no longer a quiz, right? So you know, consider your request to have a bit more time, and also, you know, I really don't want to, you know, spend too much time out of class, okay? You know, to let you take a quiz. So I'm asking your opinion, okay? So if you want to have a bit more time on the quiz, it has to be everyone start at the same time. Otherwise, no longer quiz. Okay. So and also consider that if in other time it be difficult for you know each and everyone can be available. So I'm proposing that one option is start at 7:50 a.m. Just you know, a bit before the class starts. Okay. But you can have that you know they say you know, all the time before the 8th to have that quiz. It's not too much different, but technically, I'm just a slight adjust of your schedule will make make it possible for everyone to be available at the time. 7:50, then you have all the 10 minutes for the quiz. Just the quiz questions will be the same as I said in the syllabus. Generally 4, but actually also you're going to see 5. Okay, but I'm not going to guarantee everyone you're going to see 5. Those are the 5th question extra credit. Okay, so that will be the the arrangement if you think, okay, I like that idea, or if you don't like the idea, I'll still stick to original and start at 8, and then you still have 6 minutes. So let me see how many of them are on the blackboard. If I don't have more than half the class on blackboard, maybe I can just we're doing just the manual counting of hands. Only 8. So I'm not doing the blackboard pooling because only 8 of them are blackboard collaborate. Okay. So let's say plan A. Let me see. Plan A. I just write it here. A starts. Quiz starts at 7:50 a.m. You have say not say exactly 10 minutes. Say I would say the class start at 8 a.m. So our exact start at 8 a.m. So if you start, you can have up to 10 minutes. Okay, up to 10 minutes. If you actions quick enough, you can have entire 10 minutes. If you no matter what, the quiz stop at 8. Okay, the class starts. So that's the plan A. Okay, plan B starts at 8. You have 6 minutes. So basically, you have 6 minutes. Hold on. This is up to 10 minutes. Okay. This is exactly 6 minutes. Okay. So but obviously nothing that completely no time from sky. Okay. So I'm not willing to give you 10 minutes out of the instructional hours to let you take quiz, additional 4 minutes. That's what I'm not going to do that, okay? Because as you know, our class hours are pretty precious. Okay, I rather spend on discussion not for the actual quiz. Okay, so maybe let's say how many of you prefer plan A? Just raise your hand. Okay, please hold it. Let me count. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14, 16, 15, 18, 19. Okay, so it's more than 20 already. So let's go plan A. Okay. So plan A will start at 7:50 a.m. Okay. So you're gonna have up to 10 minutes. So the quiz will be automatically available at 7:50. It's your responsibility if you want to make it use entire 10 minutes. Getting 7:49, the Blackboard collaborator, and I will not be here to. I'm not necessarily will be here to, let's say, stare at you. You can do whatever you want. Just don't talk to your neighbors. Okay, to work independently. That's only requirement. Okay, it's open book. Quizzes are open book, but you are supposed to work independently. You can use whatever resource you think can be helpful, just not your neighbors, not your friends, or not your mentors. Work independently will be fun. So now I'm gonna later I'm gonna update the syllabus, make it start at 7:50. You can have up to 10 minutes to work on the quiz. Okay. Now second point is also I have see more than one student. The number of students said, okay, we would like to have more discussions, in the classroom. Okay? More discussions, more examples in the classroom. Okay? Another thing is that also we have a constraint. That's every week we have 4 hours. Okay, we can just create terms out of thin air. Okay, so if we want to have more discussions, we have to restructure the mode of teaching learning process in this course from whatever we had last semester, so that we can enable more discussions, more examples in the classroom. So to that end, I have a proposal. So if you guys like that, the class like that, okay, we can do that, so that we can have more examples, more discussions in the classroom. But again, because time cannot be created out of thin air, there will be compromise. The compromise will be, let's say that today we're going to just, after this the discussion part, end of how we're going to run the course, and we're going to start a regular instruction. Say I cover whatever contents. Okay. Then the next class. Okay. Wednesday we are supposed to discuss the topics following what will be discussed today. Okay. But instead of are gonna be delivering the topics next Wednesday, I'm gonna post on the recorded videos, earlier. Okay, so you guys are required to watch them. Read the related, content from either your textbook or whatever resource you like to use. Then next class we're gonna have discussion. Let's say you have questions, you want to see more examples, you want to have discussions, this kind of thing. Basically, you watch the real class meeting time will be reserved for more examples, discussions, or answer your questions, instead of say delivering the new content. New content will be delivered online, using the form of recorded lecture. You understand what I'm saying? Because only have that much instruction hours. If you want to have more discussions, then we have to move the regular instructions into the form of video. Okay. And then the class meeting time becomes just okay. You have a question asked. I'm going to show you if you want to see more examples. I can give you more examples, and or we can let's say make it to study groups that give you something to work on. That's all can be done. But we need time. So that time can be saved if I upload the recorded lectures ahead of time, and you guys. You put the learning effort accordingly. Then during the regular class meetings, we have more engaging interaction. So that is just the proposal. See whether you like it, and the other proposal was just the regular one. So I'm not gonna be upload the recorded lectures earlier, and you are expected to read the corresponding topics from your textbook, most likely, or any other research material, learning material you want to use. Okay? Then I will deliver the new content next class as usual, just like typical undergraduate class. Okay? So that are the two proposals. Okay. So is that clear about these two proposals? Okay, so everyone clear. That's okay. Again, so let me write down the proposal A. So the lecture videos. available earlier. Your responsibility to watch. Your responsibility. Well, watch, but you really need to watch. If you don't watch it, you cannot have a productive discussion. Yeah.
So like, when would it be uploaded? Like on Tuesday or like?
Well, I mean, okay, I'm gonna give you sufficient long time. Let's say, I have a lot of video from past semester. I can always can find the one that fit. Okay, so so I can give you, let's say, the first class finished. I'm gonna upload the next class. So you don't have to, let's say, not suggest the night before, okay? That's the previous class finished, just upload the next one. And also, just for the sake of making it easier for you to track, I'm not gonna release all the video at one time, you know, because maybe that will make it a little difficult. Oh, which one I should watch, right? You will always watch the newest one. So that will be fun. Anyway, you're responsible to watch, digest. And then classroom, just classroom hours, discussion. Discussion. More examples. Then proposal B, regular, okay? That's proposal B. Just regular, as probably you can expect, from whatever in the past, the typical undergraduate course mode. Okay, so now, so if you like the proposal A again, please raise your hand. 1, 2, let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19. Oh, it's pretty close, seems like. Yeah.
So when you choose A, will you be going over the slides at all? Or are you just like skipping through it and asking like different?
Well, because all the slides are supposed to be during the lecture, during the recorded videos. So if it's obviously the advantage of this proposal, if there's a sizable number of students find a particular part is particularly, let's say, especially challenging, needs more explanation, yeah, just ask. You can go through again the specific part, yeah.
I have a question. Let's just say we do proposal A and maybe like something happens where it doesn't really work out. Would we be able to switch back to proposal B?
Of course. Just let's say again, we can just using this handfully if we have really more than half class. Okay, we should go back to regular. It's fine.
I think you mentioned something about like study groups or like material that you could print out that all work together.
Yeah, I mean, let's say, for instance, this for typical, let's say, maybe this special works, maybe more applicable for the synthesis questions. Okay, let's say, we can form, let's say, we have like 40 students, maybe we can form, maybe I think 4 students may be a good size of group. Too large, then some students will, they can be carried over, right? So like the 3-4 students, I think that's good size. Anything beyond that.
But would we be given like additional material?
Yeah, I mean, I could give you some new material. Just like, for instance, we can take some questions, you might expecting to see the exam, something like that you work, but not exactly the same thing you see the practice exam. Yeah, because practice is why we're going to be there. Okay, yeah, it's just kind of practice.
I changed my answer to A.
You want it also?
A.
Okay, so let's, yeah.
How long do you think the visas
He gives us more study material.
Video, it's just like a recorded class.
Yeah, like how long? So the whole 2 hours?
Yeah. But you're not necessarily getting one video. Especially, you do you won't exactly what you will get may not be exactly one video. Sometimes, let's say each semester the overall equivalence of 1 So, okay, so then we're gonna go to proposal A, okay? So we're gonna start from, the next class. This class is still, will be regular, okay? And again, if significant number of students find that this proposal does not work well, we can change.
So Mondays would be like regular and Wednesdays would be like discussion, or both days of discussion?
No, basically, because more than half students like that proposal A, so what will be happening is start from today we're going to be regular because we didn't have this discussion earlier. You're not prepared for it. But start from today, every class will be like, I will upload the record lecture first. You watch, then we discuss more example, this kind of thing. Or especially if you after you watching the lecture, you feel that one part, if more than a few students, if only one student, probably I'm not necessarily, but if say 1 or 2 students, more than 1 student, maybe 2 students, or if I don't see other requests, we can, see this part, we want you to go through, if a little more detail. Yes, that's one of very common requests, because every class may be a little different. If you feel, this part, I feel I need more discussion. Then, a few students, yeah, I agree. Okay, then go ahead, we're gonna do more detailed explanation. Yeah.
Do you want to post the weekly?
After this class ends, maybe.
No, like Saturday, Sunday, like before the class.
Well, usually let's say one class ends that day. Usually, at the most second day.
So Monday today and we will post.
Yeah, at the most let's say Tuesday, because sometimes depends on where I can source the video. Because all my previous lectures, okay? But also I have to fit the content, because some semester content may be not.
And then before Monday we will post.
So then we'll do like.
You want at least have 2 days to watch it.
So then will the quiz is gonna be based off the Monday and that second lecture, or would it be like, how would that work?
Oh, that's good question. So the let's say the quiz that will still make is basically in such a way that let's say Monday, right? Then the Wednesday you still only have the only quiz you based on the Monday. Okay. And basically so now the only difference is now before taking the quiz you have to watch the video and we discuss in class. That's the difference.
So every class will quiz.
Okay. So then that's a discussion. The quizzes. If you have read that, I'm gonna drop the 6 lowest quizzes for you. So if it's a college reason, let's say CSI Wi-Fi, this was not working, this was not working, I will drop the additional one. Okay. But if it's your reason, either you didn't configure the device well, or you didn't come, or you get up late, or even you are sick, okay? I will not give you any more adjustment because already 6, the lowest one will be dropped. Okay. A homework I talked about already. Exam, I think yes, 4 days. Likely I will stick to those days because I think they are reasonable part. At least, only the exam 2 and exam 3 they are 2 weeks apart, but all others they are well separated. So I will try best to stick to those dates. Okay. And then the 5 will be counted. So if you missed one, usually is counted as a job. So the only exception if you missed the exam because of medical reason and supported by doctor's notes, I may excuse the absence once, not second time. And I think all other things you can read. And anyone have more questions about the general policy in this course? Yes.
Are you gonna post the old exams again?
Yes. Same thing. All exams, the electric practice. but no guarantee will be the same. So any other questions? Yeah. Now we're gonna start the regular delivery of the first chapter on organic 2. So the first chapter in organic 2 is called Electrophilic and Nucleophilic Aromatic Substitution. So let's start the electrophilic aromatic substitution. So if we expect, if we are looking at the aromatic compound, the most representative aromatic compound is the benzene. That's most representative, and this also is the aromatic compound demonstrated the greatest stability from its aromaticity. So all aromatic compounds, can get a huge stabilization because of aromaticity. But benzene is the best example. So because of the aromatic structure, benzene has unusually high, stability than what you can expect from this structure. So just a refresh. What is the requirement for a compound to be aromatic? Yes.
Conjugated.
Conjugated. Yes. Very good one. That's the only one. Yeah. That is actually related to what the Louisiana, right? Yeah. Said. Because being conjugated requires all the ring atoms must be sp2 hybridized. Okay, but these are both are good point. But any other, yeah?
Resonance.
Again, this is three things that we want to say. Yeah. Yes, Huckel's rule. That's important. Basically, the number of pi electrons. Okay? So it has to be 2, 6, 10, 14, and 18. But the most common one is 6 pi electrons. The inside the monocyclic conjugate structure. And for benzene, the 6 pi electrons all come from in the form of pi bond. Each pi bond gives you 2 pi electrons. So yes, you have 3 of them. You have 6 pi electrons. 3 pi bonds. Okay, and you have 6 pi electrons. And if you just look at this structure alone, you expect, this is cyclic triene, right? Triene. So 3 double bonds. And from what we learned in organic 1, I hope you recall, alkenes, their characteristic reaction is react with electrophilic reagent. And the electrophilic reagent, has the 2 fragments. One is the electrophilic part, one is the nucleophilic part. So we call it delta plus, delta minus. And a real world example, I'll give you a few examples. Say HCl, okay? So the delta plus part is pretty much H plus, okay? And delta minus one pretty much chloride, okay? This is and also maybe I can change the. Water, okay? Water also could be electrophilic reagent. The proton part is electrophilic part, hydroxide part is nucleophilic part. And then and even I hope you recall that a halogen also can be nucleophilic reagent. So let's say Br and Br. So the Br bromide, Br2, bromine molecule can be considered a combination of bromonium cation and the bromide anode. So this is the electrophilic part and nucleophilic part. But the reaction, that effect is you're gonna see two fragments, okay? The electrophilic part and the nucleophilic part will add to the carbon-carbon double bond. And this is standard called electrophilic addition reaction, okay? So if we look at the real world examples, I'm gonna give you some example to refresh whatever, you know, you have learning organic one. Say, okay, propene react with, say, water. Let me see the color. Using red as a electrophile part, say blue as a nucleophile part. And if you have a catalyst acid, okay, so what it will be the product? You see the, you know, the proton add to here, okay, and the hydroxide add here. So that's what you learned in organic one, okay, and obviously we also can have the which one's red, which one pink? This is red, right?
Yeah.
Okay, okay. See, I'm a half color blind, so this is something I have difficult to see the difference between, to me, in my opinion, they are the similar color. So the similarly again, what you see is the this guy is it's the electrophilic part. Let's say make it red. This is red. Okay, add to the here, and the nucleophilic part add to the central color. Okay, so that is some reactions. You know, two reactions, and they are the examples of classic electrophilic addition of alkenes. Now, if you just look at this, you know, the benzene based on its Lewis structure, you expect, oh, it has 3 double bonds, so it should react with, say, HCl, capable of reacting with 3 molar equivalent HCl, and each HCl can add to the you know, double bond, right? If each double bond behave like isolated double bond, okay? But because those 3 double bonds, they actually talk to each other. They are, you know, they are basically integrated parts of aromatic system. So the reaction actually is different. First, both those two, the first two electrophiles, okay, they don't react with benzene. They don't, okay. Because why? Because the double bonds, okay, in the benzene ring, they are much less reactive because those double bonds are part of aromatic system. They are stabilized to a great deal of degree, so they don't want to react. Okay, so if you really have a very powerful electrophile, the reaction could happen. And in that case, the reaction, it's not an addition reaction. That's what you could expect from conventional CC double bond. Instead, it's a substitution reaction. So what you see is you have aromatic. If you have unsubstituted aromatic compound, say just the, you know, the benzene, just, you know, plain benzene. If you react with electrophile, the net effect is the electrophilic fragment will be replacing a hydrogen from aromatic ring. And that hydrogen will combine with nucleophilic fragment in the electrophile and become the two products. So why? Is because the ring is aromatic, okay? And exactly, it can, without looking more detailed, you can understand why it's will be less willing to react because of double bonds are stabilized by aromaticity. But why the reaction turns into substitution instead of addition, we will need to look at a mechanism, in a little greater detail, you will understand why it becomes substitution instead of the addition. So let's first look at a few representative electrophilic aromatic substitution, the reaction of benzene. Okay? So the basically, in all those examples, we will just see the plain benzene. Why that's the case? Because plain, we're using this one example because plain benzene has 6 hydrogens. Okay, so you don't have a question of which hydrogen gets substituted. Okay, so that makes the the reaction simpler to study. Okay, and then let's look at what kind of the electrophilic reagents we can have. Okay? So then the first and also I want to show you when we look at each electrophilic reagent in this electrophilic aromatic substitution reaction, I want to suggest you to always view those reagents as a combination of 2 fragments, okay? A nucleophilic fragment and an electrophilic fragment. Okay? So first electrophilic reagent we're going to look at is this guy, nitric acid. Okay? Nitric acid usually, you probably know, usually we write as HNO3. Okay? But here, to signify its electrophilic fragment and the nucleophilic fragment, I'm going to write from now, let's say, the electrophilic fragment I write in red, okay? Nucleophilic fragment I write either blue or green. Sometimes, just forgive me, my color picking may not be accurate, but just color color, okay? Assume it's the nucleophilic. The warm color is the electrophilic. Okay? So let me see. So in the nitric acid, obviously can have the hydroxide fragment. Okay, this is a nucleophilic one, and then the H3. Okay. Oh, is this red? Okay, this is red. To add together still is HNO3. Okay. So basically, nucleophilic part is OH, and the electrophilic part is NO2. This one later you will see name called nitrogen cation. Okay, but not talk about it. Okay. So what happens is this, this electrophilic fragment will be replacing hydrogen on the aromatic ring, become nitrobenzene. Okay. Name again. It's not big deal, but I guess because this group we'll see so frequently, you better know its name. Just called nitro group. Okay. Nitro group. Okay. And then the remaining part is this H combined with this H, give H2O. Okay. And the second, the electrophilic agent. So see, just the acids, they due to having the the highly electrophilic protons, they are natural electrophilic reagents, usually acids. Okay, so but just hydrochloric acid, hydrobromic acid, or hydroiodic acid, those hydrogen halides, they are not reactive enough to react with benzene. You need a nitric acid and a sulfuric acid. It's not that, let's say, those acids are not acidic enough, just they are not electrophilic. So basically see here, acids, because of having protons, so they can be electrophilic. But here, those acids obviously you can see, because if it's because of the reactivity of protons, HI should be more reactive as an electrophile here. But in those reaction with aromatic compound, the actual electrophilic reagent is not proton, something else. Okay, like the nitric acid. What you can see, the electrophilic reagent actually is later you will see NO2+. Yes, Andrew.
So is the nitric acid and the sulfuric acid the only 2 acids we have to worry about in electrophilic aromatic substitution?
Kind of. No, only 2 kind of protic acid. We will see some Lewis acid. Okay, but but kind of yes. So the second one, sulfuric acid. Okay, sulfuric acid again. We will write it as the combination of nucleophilic fragment and electrophilic fragment. And nucleophilic fragment again is OH. So let me see. This blue. Okay. So we write as OH, the nucleophilic part, and the remaining part will be the electrophilic part. So so this remaining part is electrophilic. Okay. So the in the reaction, the electrophilic part replaces hydrogen in the benzene, and then these two guys, okay, the hydrogen on the benzene will be replaced, combined with nucleophilic part, give you the other product. What? Any questions to this point? And the halogen molecules, elementary form of halogen, say chlorine, bromine, that's the most common one. It's fluorine and iodine, they are very uncommon. And the fluorine becomes overly reactive, uncontrollable. Iodine is too slow to be reactive. But the basic chlorine and the bromine, they are the real reaction. They are really used for elementary form of halogen to carry out nucleophilic, electrophilic, the aromatic substitution. So bromine Br2 we can write as the red part of the bromium ion is the electrophilic part. The blue part is the bromide. Okay, that's the nucleophilic part. So obviously the red one can replace hydrogen, and then these two guys, okay, the proton, okay, and these two, they combine into HBr. Those are the reactions. And even alkyl halide, okay, can serve as the but the alkyl halide, the itself, as you know, is not a very powerful electropile. Alkyl halide has been served as electropile for nucleophilic substitution reaction. We have seen many examples in organic one. And we can write alkyl halide as the chloride part, okay, let's say. And then that's the nucleophilic part. And the electrophilic part is this one, okay? So the electrophilic part, they replace proton on the benzene ring, give you alkylated benzene. And the nucleophilic part, okay, combined with the proton, give you hydrochloride. And the reason that the alkyl halide can serve as an electrophile is because the carbon, okay, is substantially less electronegative than halogen. So this gives you the partial positive charge on this carbon. So makes this carbon, give the carbon the ability to serve as electrophile. Right? That's what we discussed in organic one. So if you place a CO double bond, basically if you have an oxygen double bond to this electrophilic carbon, then you have this kind of compound called acyl chloride, and you don't need to remember the name acyl chloride. And but you will see this name many times, so maybe you should start be familiar with this. Okay? So if you have compare this carbon, okay, and this carbon, which carbon is the more electrophilic carbon? The bottom one or the top one? Bottom one or top one? If this carbon or this carbon, which carbon is more? Bottom one, because of CO double bond, okay, the O double bond to the carbon will substantially increase the positive charge of the carbon. So makes that carbon even more electrophilic than the the alkyl carbon you see earlier. Okay. So the acyl chloride in general even is substantially better electrophile. This carbon is much more electrophilic than this carbon. So and then we can write this carbon, this compound. If let's say using let's color code it, the electrophilic part is the warm color. I try to make it red, but sometimes I put wrong color. Sorry, but still you can see the warm color. Okay, so so this is the electrophilic part. Okay, and then and this one is the nucleophilic part. So the electrophilic part will be replacing proton on the aromatic ring. And the nucleophilic part combined with the proton give you the other product. So let's look at a few, let's say, just a few more real-world examples. Okay. So let's say benzene. Okay. React with this one is basically you're gonna see although in typical reaction you don't need to care about the inorganic product, but you probably still it's better to know you're gonna have the water product. Okay? And then when we talk about mechanism, you will know a bit better of reaction condition. Okay? So if you have this thing is a catalyst. We're gonna explain why we need this catalyst later on. Okay, but this is a catalyst. So what you'll be seeing is this one can be viewed as BR, this. Okay. I purposely this bond is part of nucleophilic fragment. Okay? So this one is electrophilic fragment. So you will see this thing become and the product HER. And the similar and again, we will need a catalyst. Okay, and why we need this catalyst, we're going to talk about later on. But the reaction is so these are the reactions. All right, maybe let's have a, let's say, 7 minutes break. It's 9 o'clock.